Hello students, by this video let us try to balance a redox reaction by ion electron method. So the redox reaction is potassium permanganate plus FeSO4 plus H2SO4 gives MnSO4 plus Fe2SO4 thrice plus K2SO4 plus water. So this is the redox reaction. So by ion electron method, the first step is to find the oxidation number of each element in the compounds of both reactant as well as the product. So that is your first step. Yes, and check out which atom undergoes oxidation and reduction reaction. So that is our first step. Fine. So let us now find the oxidation state for different elements in these compounds. Okay, now let us take first potassium permanganate. Okay, so here let us start with oxygen. Oxygen, the oxidation number is -2. So here 4 oxygen atom is there. So the oxidation state will be, for 1 oxygen atom it is -2, then for 4 oxygen atom it will be -8. It will become -8. Now for manganese and potassium we have to find out. So this potassium permanganate molecule, the charge is always neutral. For a molecule the charge is always neutral. So only for oxygen it is -8. Then for potassium and manganese together it should be +8, right? So in this +8, oxidation number for +1 potassium. For potassium it is +1. For manganese then it will become +7. So +7 plus 1 is +8. +8 minus 8 becomes 0. So the molecule charge neutral 0. Fine. So now we found the oxidation state for manganese +7 and potassium it is +1. Fine. Now FeSO4. Likewise here also for oxygen it is -2. So 4 oxygen atom is there, so -8. So remaining oxidation state for iron and sulfur it should be +8. Yes. Then for iron it is +2 and for sulfur it is +6. Okay. Now, so +6 plus 2 gives +8. +8 minus 8 becomes 0. So this molecule charge will be 0. Okay. Now let us see the oxidation state for sulfuric acid, H2SO4. So for oxygen we will consider -2. So for 4 oxygen it become -8. Then for sulfur it becomes +6. Then for hydrogen it is +1 generally, but 2 hydrogen atom is there, so it becomes +2. So +2 plus 6 become +8. +8 minus 8 becomes 0. So likewise that charge of that molecule neutral. That is also found out. Now here in the case of manganese sulfate, oxygen it is -2. So for oxygen atom -8. So these two elements should have the charge of +8. So in that sulfur will be always +6. Then what will be manganese? Manganese will be +2. So 6 plus 2 is +8. +8 minus 8 becomes 0. So now we found for manganese oxidation state is +2. Now for FeSO4. So for FeSO4, SO4 together it is an ion. Okay. So this charge of this SO4 ion is always -2. So here 3 SO4 ions are there. So -2 into 3, so it gives you -6. Then here it should be, so this is ferric sulfate, Fe2SO4 thrice, ferric sulfate. Yes. Then here for iron it should be +6. So +6 means for 2 iron Fe atom it is +6. Then for 1 Fe atom it should be how much? +3. Okay. So we found the oxidation state of iron also. Now for potassium sulfate, for oxygen it is -2. So it becomes here -8. Then for sulfur it is +6 and for potassium it is +1. So for 2 potassium it is +2. Okay. So +2 plus 6 become +8. +8 minus 8 becomes 0. Okay. Now for water. So water is a simple molecule. Fine. So what should we do? I just split this water into 2 halves. The first half I give the charge plus and second half I give the charge minus. Now hydrogen 2 atoms are there, so this 2 I just put here. So oxidation state of oxygen become -2. And here oxygen only 1 atom. Yes, there is no number here written here, but still we consider it as 1. So oxygen 1 atom. So here near to plus, I just put here 1. So for hydrogen become plus 1 and for oxygen becomes minus 2. So now we found the oxidation state for all the elements present in the compound. Now in the second step, what should we do? We have to write the ionic form. So before writing the ionic form, we have to find which is the atom which undergo oxidation and reduction. So we have to check out which atom is having a change in oxidation number. Now here potassium, it is plus 1 oxidation state, whereas here S again it is plus 1. So there is no change in oxidation state. Now for the manganese, it is plus 7 here, whereas on the right hand side manganese is plus 2. Yes, there is a change in the oxidation state. Yes, so for that reason what should we do? We should mark it. S. We write the reaction once again. S. Yes, in order to make the ionic form of the redox reaction, I have written the reaction once again. So now we have to find we have to write just only the ions which undergo oxidation reduction, only those ions we should write in the ionic form, okay, of the redox reaction. Yes, so now what should I do? I just split each compound into plus and minus ion. So potassium is always plus ion and manganese MnO4, this is minus ion. Likewise, FeSO4, Fe is a plus ion, SO4 is a minus ion. Yes, then here H2 also, here it is plus and this is minus, and here manganese also plus, SO4 is minus, here Fe2 plus, SO4 minus, potassium plus, SO4 minus, and here water, H2 plus, O minus. Yes, so that means we have split the ions into, that means the compounds we have split into ions, positive ion and negative ion. So first half is positive and the second half is your negative. Okay, so here only positive ions we write. Okay, but in this case, here potassium oxidation state is plus 1, whereas on the right hand side also potassium it is plus 1. So we need not write. Oxidation state is both the sides it is same, so need not write. Whereas MnO4 I have to write because MnO4, in MnO4, Mn is undergoing reduction reaction. Okay, so for that reason I just write this MnO4. Okay, so in MnO4 and I write the charge minus plus, here I write only the positive ions, I write Fe plus, here also I just write hydrogen plus, only hydrogen, for one atom only I write, I don't write both the atoms, only one atom. Okay, gives here Mn plus Fe plus, here also Fe2 is there, so I just only write 1, so Fe plus, and here potassium sulfate, here because I did not write here K, here also I don't write because both the side the charge is same, so need not write. Okay, then plus water molecule, so water I write it as it is. Okay, now I have written the ionic form. Now in this ionic form, this is the ionic form of the redox reaction. Now from this reaction I have to separate into oxidation half and reduction half. Okay, so now this ionic form I have to separate into oxidation half and reduction half. Fine. So I just write here oxidation half reaction, and here it is the reduction half reaction. So the ion which is undergoing oxidation, so that only I will write this side, whereas on the right side the ion which undergo reduction reaction. Okay, so that I just write here. So I will just underline. Now what is undergoing oxidation? Fe plus is undergoing oxidation to Fe3 plus. Yes, now after writing the ionic form, Fe oxidation state I have to write it completely. Here I have written only plus, so it is plus 2. Okay, likewise here manganese, here it is plus 2, and here Fe plus 3. Okay, so this I have to write it as it is. Okay, now. So MnO4 the charge is minus, so that only I write. I need not make any change in that. In that Mn is plus 7. Yes. Okay. So now I just write the oxidation half. Fe plus 2 gives Fe plus 3. So this is the oxidation half reaction. Okay. Now I write the reduction half reaction. So reduction half reaction is MnO4 minus ion plus H plus I write. H plus gives Mn plus 2 plus H2O. Okay, so oxidation half and reduction half I have written. Now what should I do? Now I have to balance all the elements leaving oxygen and hydrogen. So let us see the balancing. Here one Fe, here also one Fe, so that is balanced. Now in the reduction half, here one manganese, here also one manganese, that is balanced. Now here one hydrogen, whereas here two hydrogen. Here one oxygen, here four oxygen. So for that reason, what should I do? I just put 4 here. So when I put here 4, it becomes 4 oxygen. So 4 oxygen is balanced. Okay. Then here 8 hydrogen is there, whereas here only 1 hydrogen, so I put here 8. So that is also balanced. Okay. So first all the atoms are balanced here. So first, other than oxygen and hydrogen, we have to balance all the atoms. Then after that, we have to balance oxygen and hydrogen. Okay. Now after this, we have to balance the charges on both the sides of oxidation half and reduction half. So here the charge is plus 2, whereas here the charge is plus 3. So there is a difference here. Yes. So in order to balance the charge, I just add here 1 electron. So 1 electron means plus 3 plus 1. So plus 3 plus 1, plus 3 minus 1, because charge of the electron is minus. So plus 3 minus 1. So plus 3 minus 1, how much? It is plus 2 minus 1. So it gives you plus 2. So now this side it is plus 2, even this side also plus 2. So the charge is balanced in the oxidation half. Now in the reduction half, let us balance here. Here it is minus 1 and here it is plus 8. Because for hydrogen it is plus 1, 8 hydrogen atom is there, so plus 8. So minus 1 plus 8, so that gives you plus 7. So in this side the charge is plus 7. Whereas on the right hand side the charge is plus 2. Right hand side charge is plus 2. So in order to balance the charge, I just add here 5 electron. Yes, I just add 5 electron here. 5 electron. Yes, so when I add 5 electron, what happens here? So plus 7 minus 1. So electron, 1 electron is minus 1 charge, so 5 electron minus 1. So plus 7 minus 5 gives you plus 2. Now here the charge is plus 2 and on the right hand side also plus 2. Now the charge is balanced in the reduction half reaction as well as the oxidation half reaction. Understanding? Clear? Fine? Now what should we do? Now the charge is balanced. Now these two, oxidation half reaction, reduction half reaction, we should add and write. So before add and writing the oxidation half reduction half, we have to balance the electrons both the side. Now oxidation half 1 electron is there, whereas on the reduction half 5 electrons. So electrons are not equal on both the sides, both reactions, oxidation half and reduction reaction. So in order to balance the electron, what should I do? I just multiply this oxidation half with this 5. Okay, and reduction half I multiply with this 1. Yes? Okay? Oh, fine. Now I write the reaction once again by multiplying by 5. So when I multiply 5 into Fe plus 2, it becomes 5 Fe plus 2 gives 5 Fe plus 3 plus 1 into 5, 5 electron. Okay? Now on the right hand side, that is the reduction half also I just write. So here also I multiply by 1 both the sides. So here 1 into MnO4 means MnO4 ion plus 1 into 8, 8H plus ion gives 1 into Mn, so 1 Mn plus 2 ion plus 1 into 4, 4H2O. Yes. So now number of electrons on both the sides are equal. Yes. Then here 1 into 5, 5 electrons are there. So that's why I write here 5 electrons. Now electrons are equal on both the sides. Both oxidation half as well as the reduction of the electrons are equal. Okay. Now what should I do? Now I should add oxidation half reaction, reduction half reaction. I have to add. Okay. So first I write the longer reduction half reaction first. Now I have written the oxidation half and reduction half reaction I have written. Okay, now I am going to add. So while adding, what should I do? I should cancel the electrons. Okay, I am cancelling the electrons. So here 5 electron on the left hand side and 5 electron on the right hand side balanced. Okay, now what is left remaining? Remaining whatever is left, I just write here. MnO4 minus plus 8H plus 5Fe plus 2 gives Mn plus 2 plus 4H2O plus 5Fe plus 3. Okay, now this is your balanced redox reaction. So now let us count the number of elements on both the sides. So here 1 Mn, here also 1 Mn. Here 8H plus ion, that is 8 hydrogen, here also 8 hydrogen. Here 4 oxygen, here also 4 oxygen. Here 5 Fe, here also 5 Fe. Now the redox reaction is completely balanced by ion-electron method. Fine. So hope you understood this video. Thank you.